Hey everybody, in today's video I'm talking about the Collatz Conjecture, and I'll also be showing a program I made in Python that shows the conjecture in work and also helps visualize with a graphing portion. So what exactly is the Collatz Conjecture? Well, it's a mathematical sequence in which you pick any positive integer on the number line, and simply, if that number is odd, you multiply it by 3 and you add 1 to the product, and if the number is even, you divide it by 2. And then what you do is you take your end result, whether you multiply by 3 and add 1 or divide by 2, and then you reiterate through those same sequences over and over. And according to the conjecture, eventually you will always reach an end value of 1. So here on the Wikipedia page you can see there are some arithmetic notations of the conjecture. And so essentially what's happening is you test the number to see if it's odd or even by dividing it by 2. And if the number has a remainder when divided by 2, that would mean that it's not odd, seeing that all even numbers can be divided by 2 evenly. And if there is no remainder, obviously that means it's an even number. And so if there is no remainder, you divide it by 2, and if there is a remainder, you multiply by 3 and then add 1. So moving on to the program that I made. Here it is. It's around 50 lines of code, and in this program I used the interpreter for Matplotlib. And so essentially how this program works is there is an evaluation for a user input where it'll ask you to pick a number, at which point you can type any number you want. It'll evaluate what number you put in and set that equal to the variable of num, which is just short for number. And then so down here you can see that I set another variable equal to 0 for iterations. You'll see where that's going to come up later. And also the variable complete equal to false, and you'll also see that later in the code. And then down here I'm setting all of these variables global, so that way even though they're outside of the function here, I'll be able to access them inside of the function. And so how this works is I have this while loop, which is while complete equivalent to false. This is going to continue to iterate. So that way, here, when you see it's testing, if number divided by 2 has a remainder equivalent to 0, then take the number, divide it by 2, and set that new quotient equal to number. And then here, if number divided by 2 has a remainder that is not equivalent to 0, then take number, multiply it by 3, take that product, add 1, and set this whole value equal to number once more. And then if number is equal to 1, complete equals true. However, if it goes through these two steps here and does not come all the way down to 1, then complete will not be equal to true, at which point it's just going to keep on running through this while statement. And so you can also see that each time it's multiplied by 3 and has 1 added, or each time it's divided by 2, iterations goes up by 1. So essentially each time the number goes through the sequence, it has 1 iteration added, just so you can count how many times the number had to go through the sequence in order for it to reach 1. And so each time iterations goes up by 1. And then you can see here that I put all of this in the while statement, and of course that'll stop once complete equals true, and that's essentially the end of the program. And then I also have these numbers then export into Matplotlib which essentially just graphs it using these lists. So here I'm going to show you how it works. We're going to run the program. So pick a number. Let's just choose anything, 41, just a random number. It shows up the graph. Here it took 109 iterations of the code to reach 1. And you can see all the numbers. So 41, obviously that's an odd number. So you're going to multiply it by 3. You're going to get 123, add 1. There you go, divide by 2, and then you can just see it's obviously going through the sequence over and over until you reach 1. And then here you can also see the graph that really shows all of the steps that the number is going through, and you can see 2 peaks here, and then eventually lowers down all the way to 1. And that's going to take 109 iterations. Now we can try it with another number, really any number you want. We can go as low, like anything you want really. 4, pretty simple really, just 2 iterations, so not much to see there. But if you want to pick something bigger, we can do, let me just type a bunch of random stuff into my keyboard, hit that, 236 iterations to get it. You can really see just all the steps it took. It really didn't peak all that much except the very first iteration there. And I think you guys are starting to get an idea. Just one more, jam a couple more numbers in. Let's make this one odd. 422 iterations. Another interesting chart. You can see it really peaks at the start, but by the end it starts to level out and then eventually reaches 1, just like all the rest. And that's essentially the code in the program. I hope you guys enjoyed, and thanks for watching.